Today, we're going to discuss paper 4, October November 2024, variant 1. Let's begin with question number 1. For question number 1, two particles mass of 1.8 kg and 1.2 kg are connected by light inextensible string. Passes through a smooth pulley, the particles hang vertically. So first, we just draw a simple diagram. Okay, so a pulley. Okay, so the first object and the second object. Okay, then one is 1.8 kg, so this is 1.8 and this is 1.2. Let's assume like that. Okay, the system is released from rest. So at this point, the system is released from rest. Find the magnitude of acceleration and part of the particle and the tension of the string. Okay, so here we need to find the acceleration and also tension of the particles string. Okay, then, so when this object is released from rest, so the heavier object will go downwards and lighter object will go upwards. So one will go down, one will go up. Okay, so the forces involved here, so first it will be the weight. So for this 1.8, so the weight will be mg, will be 1.8 g, and for this weight is your 1.2 g, and the tension here will be t, and the tension here will be t. Okay, so here we need to find the acceleration and tension, so we're going to use the Newton's law, where is F equivalent to ma. We're going to use this. Okay, where F will be your net force, m is the mass of the particle, and a is the acceleration of the particle. Okay, so we divide this system into two. So this will be your, we divide this into two. So the first system here, where the object will go downwards because this object is heavier than the another one. 1.8 is heavier than 1.2, so the 1.8 will go downwards. Okay, so we choose the direction of a motion as a positive direction. So for this case, it's going to be the weight 1.8 g minus the tension is equal to 1.88. So you can rewrite, so tension plus 1.88 equal to 18. So this will be your first equation. And for the second equation, we use the second system where 1.2 g and t. So we apply the similar Newton's law. Since here the object is moving upward direction, therefore your t is in positive direction. So your t minus 1.2 g is equivalent to 1.2 a. Okay, you can rewrite. So t minus 1.2 a is equivalent to 12. So equation number 2. So solve equation 1 and equation 2. Then you will obtain your t equivalent to 14.4 and your a equivalent to 2. Okay. So here you just need to know to decide which direction is positive and which direction is negative. Okay, question number 2. A particle mass of 7.5 kg starting from rest at A. Slide down incline AB. At point B is 1.25, 12.5 meter vertically below of A. Okay, so it's something like this. Given that the plane is smooth, so if the said plane is smooth, then your frictional force is equivalent to 0. Okay, and then use the energy method. So the question very specific to the method that you want to use. You have to use the energy method and find the speed of B, speed of particle at B. Okay, so for this, usually what I will do is, okay, so we just identify what are the energies or what are the work done against any forces on your A and your B, and then we equate. Because as what we know, the energy cannot be destroyed. So the energy will be converted from one form to another form. Okay, like for example here, the energy involved going to be your, we start with kinetic energy, potential energy, okay, and since the object start at rest from A is given as rest, so your kinetic energy is equivalent to 0. Your potential energy, since it is at a height of 12.5, therefore there will be a potential energy, there is a height, okay, and then there is no any force that make the object to go down. There's no any extra or any external force make the object to move, so we don't use any work done. And similarly for this at B, we will have a kinetic energy because we're going down, so there will be kinetic energy, so we'll use half mv square. Your potential energy, since I took this as my reference height, okay, this is my reference height, so my potential energy, the height of B from my reference point is 0, so potential energy is equal to 0. And since there is smooth plane, so there is no frictional force, so there is no work done by any force. Okay, so energy at A, which is mgh, so m will be 7.5 times g is 10 and h is 12.5, is equivalent to half. Your m is 7.5, v square, we don't know the v square. Okay, so you can rearrange the equation. So it's going to be v square equivalent to 250. Therefore, your v will be cert 250. Okay, or you can write 5 cert 10. Okay, for B, it is given instead the plane is rough and the particle reaches B with a speed of 8 meter per second, and the plane is 25-meter long and the constant frictional force is F. Find the value of F. So now it's a similar idea. So we just, oh, I just, okay. So I just duplicate this. Okay. So here, now they said there is a frictional force F. Okay, there is a frictional force F. So there will be a work done by frictional force. So it's going to be F multiplied with S. Okay, so the energy on top remains the same because there is no any initial push or initial force applied on the particle. So there will be only potential energy, and kinetic energy is equivalent to 0. Okay, so mgh, where m equal to 7.5, gh is equivalent to half m v square. The question here mentioned the v is 8. Okay, so it's 8 square plus the work done by the frictional force will be F multiplied with S, and the S, the distance of this AB, this plane will be 25. It's given in the question. Okay, so it's going to be multiplied with 25. Okay, so you can rearrange this, so you'll get your F is equivalent to 27.9. Okay. Question number 3. A coplanar forces of magnitude 52 and 39 and P act on a point direction given by this system. Find the value of P and Q. Okay, so here if you notice, the P is not in either x or y direction. So what we do, we resolve all the forces into x and y direction. So for this, so if you resolve P, so this will be P cos theta, and this will be your y direction, P sine theta. And since they said the object is in equilibrium, okay, the forces are in equilibrium, sorry. So what we can say, the upward forces equivalent to downward forces. So P sine theta is equivalent to 52. Yeah, correct. And P cos theta equal to 39. Okay, so we find the P first. So let's say this is equation 1 and this is equation 2. So 1 square plus 2 square. Okay, so it's going to be P square sine square theta plus P square cos square theta is equivalent to 52 square plus 39 square. So you can factorize your P square. So it will be sine square theta plus cos square theta, which is going to be 4225. So sine square plus cos square is equivalent to 1. Therefore, my P square equal to 4225. Therefore, my P is equivalent to 65. Okay, and in order to find the theta, so what I can do, so we can put equation number 1 divided by equation number 2. So P sine theta over P cos theta is equivalent to 52 over 39. So P and P you can cancel. Therefore, tangent theta is equivalent to 52 over 39. You can press your calculator to obtain your theta, which will be 53.1 degree. So normally for degrees or angles in the degree, I will give you in one decimal place. Okay. Question number 4. A bus travel between two stop A and B. The bus start from rest and accelerate at a constant rate of A. So means it move in a constant acceleration, okay, until it reaches a speed of 16. It then travels at a constant speed for before decelerating at a constant rate of this and coming to rest at B. Total journey is 240. Okay. So here there's a three different segment. Okay, three different segment. So first, the object is accelerate at a constant rate of A until reach speed of this. This is the first part or first segment. The second segment is travel with the constant speed, and your third segment will be decelerating constant rate of this and coming to rest at B. Okay, so for the first part, since we start from zero rest, we can start from zero. Okay, so this will be 16 because it's given 16. Then it travels for constant speed, and then will be decelerating. Okay, and total journey is 240. Okay, the only thing that you need to take note is Wait, sorry. Ish, I think I make a mistake. The gradient of this. Okay. The only thing you need to take note is actually the gradient of my third segment must not steeper than the second gradient, because you see this is A and this is 0.75A. So this gradient is higher value compared to this. Okay, so the gradient of my third segment must be slightly lower than the gradient of my first part or first segment. Okay, and then find an expression of term in term of A for the total time that bus travel with a constant speed in term of A. Okay, so constant speed, maybe I put something like this. So this is my constant speed time. So I just put as capital T, for example, and then I can put this as my T1 and this as my T2. So what I know, okay, my acceleration at the first part is actually A. So A is equivalent to 16 over T1. Therefore, T1 equal to 16 over A. Similarly, 0.75A is equivalent to 16 over T2. Okay, so my T2 will be 64 over the 3A. Okay, so total time T1 plus T2 plus sorry plus T plus T2 is equal to 240. Therefore, my thought the time that we travel with a constant speed with a capital T, which will be 240 minus 16 over A minus 64 over 3A. Therefore, T will be 240 minus 112 over 3A. Okay. For C, the distance from A to B is 300 meter, 3000 meter. Find the value of A. So here we can use the what we call area under the graph. So this is a trapezium. This is a trapezium. So it's going to be 1 over 2 multiply 240 plus T, 240 plus T multiplied with height 16, which is going to be 300. So from here, T is equivalent to this. So you can just rewrite 1 over 2 times 240, and I take the T from part B plus 240 minus 112 over 3A. Okay, this one I took from part B, multiply with 16 is equal to 3000. Okay, so simplify this, you get 480 minus 112 over 3A, 3000, not 300, 3000 divided. This will be 375. Therefore, 112 over 3A will be minus, I get 105. Therefore, my A will be 16 over 45. Okay. Question number 5. A particle is projected vertically upward from point O with a speed of 80. So I just rewrite the information given to me. So particle A, the initial speed is 80 meter per second. Okay, and the 1 second later, so after 1 second is the second information. So 1 second later, particle B, same mass. So they're having a same mass, vertical upward with speed of 100. Find the time t seconds after particle projected. The two particle coalesce. Okay, after t seconds, the first particle projected, the two particle collide and coalesce to form a particle C. Show that capital T is equal to 3.5. Means after after the particle A projected, after 3.5 seconds. Okay, so for the first part, my UA is equivalent to 80. So what we do, the time that the A travel before the collision is T. Similarly, for UB will be 100, and the time that they collide will be T minus 1, because the particle B is projected 1 second later. Okay, after 1 second. So if A travel for T seconds, then B will travel T minus 1. Okay, so you can use during their collision, we can have the distance that traveled by A must be equal to the distance traveled by B, or displacement, doesn't matter. Okay, the displacement or the travel by A is equal to displacement traveled by B. So for both, they are moving under gravity, so your A will be negative 10. Okay, for both of them, because A and B is moving vertically upward and downward, so it's fixed. Your A is negative 10 for this case. So we can use the Seward formula, where S equal to UT plus half AT square. Okay, you can use this. So it's going to be, for A, it's going to be 80 T plus half A T square is equivalent to 100 T minus 1 plus half A T minus 1 square. Okay, so we simplify this, you'll get 80T minus 5T square is equivalent to 100T minus 100 plus minus 5 t square minus 2t plus 1. So it's going to be 100t minus 100 minus 5t square minus plus 10t minus 5. So 80t minus 5t square. So 5t square will cancel each other. So you rearrange, I'll get 130t is equivalent to 105. So t equal to 3.5. Okay, so it's shown. Okay, and then find the height above O at which the particles collide. So we can just substitute the t inside. You can use your SA. So for SA, it's going to be UT 3.5 plus half AT square. Okay, so you calculate. So you should get 218.75. Okay, find the time from A being projected until C returns to O. Means, so let's say the A is projected from here. So the object is going this direction. And then let's say at this point, A and B collide and become C. Okay. And due to the inertia, the object will remain to go upward until it loses all its velocity, and then will come down. Okay, so means the object C will go upward with something initial velocity, and then will go to the original position where the distance here is 218.75. Okay, the object at this point, the coalesce becomes C, and then the object will continue to go up, and then it will go down. Okay, so we try to find the speed of the object here after coalesce. Okay, so for that we use these two things, where for velocity of A at this point will be initial minus AT. Okay, so it will 45, and for VB it will be 100 minus 10, and since the object only travel for 2.5 seconds, remember this, now the this is T, for B will be T minus 1, so will be 2.5. Okay, so your VB will be 75. Okay, by using the conservation of momentum, M1 U1 plus M2 U2 is equal to M1 plus M2 V. Why I put M1 plus M plus N? Because they say they have a same mass. Here the mass of A and mass of B is the same, so I just put as an M. Okay, so it's going to be 120 M equal to 2 MV. Therefore, V equal to 60. Means the object is going upward direction with the speed of 60. Okay, so we can use S. So the object need to go down to 118.75. Okay, so it needs to travel down from this point, from this point. From this point, the object needs to travel down about 218.75. So it's going to be S negative 218.75 is equal to UT. So it will be 60T minus or plus half AT square. Okay, so you try to solve this. So will be negative positive 5T square plus 60 minus, not plus, minus 60T minus 1218.75 is equal to 0. Okay, then you can use your quality equation, which is your T equal to negative B plus minus square root B square minus 4AC over 2A. Therefore, your T is equal to 14.9. But the question here asking, find the time from A being projected until C return. So means from the time that you start here, go up, coalesce, it go up and down. So for it to go up and down is 14.9, and for the object A travel this distance 218 is actually 3.5. So the total time will be 14.9 plus just now is 3.5. This one is the answer from A. Okay, so it will be 17, 18.4 seconds. Okay, question number 6. For question number 6, a particle mass of 1.2 kg is placed on a rough plane which incline theta, so sine theta equal to 7 over 25. The particle kept in equilibrium by horizontal force magnitude acting. Okay, the question friction is this. Find the least possible value of P. Okay, they said the object is kept in horizontal. So, and the question here said find the least possible value of P. So here there's a two different situation, to be honest. Okay, So this, when you're applying the P, the object can go up the plane or the object can go down the plane. These are two different possibilities. Let's say you don't give enough force, then there's a possibilities for the object to go down. Or if you give additional or extra and force, then the object will go up. So here they said least possible, means you are giving a very minimum force in order it to be a equilibrium. Okay, you are just providing a very minimum power for the particle to be equilibrium. Therefore, we assume the object is about to go down because this is a very minimum energy that you put in. So now, when the object is about to go down, this is the direction of motion. Therefore, my frictional force will be go up. So this is my frictional force. And here there will be your normal contact force R. And here will be your mg. And for this case, usually I will use my what we call x and y Cartesian as my the slope. So here this will be my x axis and this will be my y axis. Okay, so theta theta. Okay, so on top for this it's going to be mg cos theta, mg mg sine theta. And another one for p also you can do here. So the p will go, when you resolve it will go in this direction, will be p cos theta, and here p sine theta. Okay, okay, these are the forces that we resolve. So we already resolved my p, mg things. So we can redraw this diagram, okay, if you want. So there will be a, on this direction will be a frictional force. There will be a p cos theta, and this direction will be mg sine theta. Okay, on the horizontal. And for vertical there will be a r and there will be a mg cos theta and p sine theta. Okay, so since the object's in equilibrium, so we can say F equal to ma, F equal to ma for the horizontal, where a equal to 0, so F equal to 0, net force equal to 0, which means mg sine theta is equivalent to Fr plus P cos theta. Okay, and for vertical there is no motion in vertical, so it's also is equal to 0. So upward force, my R is equivalent to mg cos theta plus P sine theta. Okay, so from here we can say it, we can draw a rectangle triangle. Okay, so here is theta, so 24 is here. So, and we must know that my frictional force is equivalent to mu r. You must know this. Okay, now we sub in everything. So my m here is 1.2. So 1.2 g is 10. Sine theta is 7 over 25 is equivalent to my mu is equivalent to 0.15. You can refer here. Okay. R is mg cos theta will be 24 over 25 plus p 7 over 25. Okay, so fr plus p cos theta 24 over 25. Okay, I fr will be this is your fr, and p cos theta. Okay, so now you can try to solve this. So if you expand this, it's going to be p, so p 24 over 25 plus, when I multiply in, it's going to be p 21 over 500 plus 1.728 is equal to 3.36. So p 501 over 500 is equal to 1.632. Therefore, my p is equal to 1.63. Okay, correct the three significant figure. Okay, so that will be the least possible value of p for it to sustain to be in an equilibrium. Okay, question number 7. A car has a mass of 1200. When the car is traveling at the speed of v, the resistive force is kV. Find the maximum power of car engine is 92.16 kilowatt. The car travel along straight road. The car has the greatest possible speed is 48. Show that k equal to this. So the power formula is actually the power is equal to Fv. So my F is kV. So kV V is equivalent to P is 92.16 kilo. Okay, so my K is actually this is my F. Okay, kV. So will be kV is 48 equal to 92,160. Don't forget there's a kilo here, so you must multiply with 1000. Therefore, my k is equal to 40 shown. Okay, but two, at an instant when the speed is 45, find the greatest possible acceleration. Okay, so at the speed of this, so it's going to be same. Your Fv is equivalent to power. So the Fv here is going to be we're talking about the car. We're talking about the car. So it's going to be driving force. So driving force multiplied with 45 is going to be P is just now is 92,160. 92,160. Therefore, my driving force will be 2048. Okay, so what we know, my net force F equal to ma. Okay, so the car is moving in this direction, let's say. So this is the driving force, and the resistance force is here. Therefore, my driving force, since the object forward direction, is going to be 2048 minus my resistance force K is 40 and V is 45. So remember this, your kV is kV equivalent to m. What is the m just now? 1200. So m is 1200 A. Therefore, my A is going to be 31 over 150. Okay. B. The car now travel at a constant speed. So when I say constant speed, my A is equivalent to 0. Remember that. Okay, constant speed a equal to 0, and up the hill incline at sine shift sine. So let's say this is the angle. Sorry, this is the hill. So let's say this is alpha. So the object is here, the car is here. Okay, so sine alpha equal to 0.15 to the horizontal. Okay, find the greatest possible speed of the car going up the hill. So here there will be a mg, there will be a r, there will be a driving force, there will be a fr, resistant force. Okay, since they said we can use net force F equal to ma, net force equal to ma. So since they said constant speed, so this will be 0. So here my net force will be, I need to resolve this. So here is my alpha. So it's going to be, since the object is moving forward, so driving force minus frictional force minus mg sine alpha equivalent to 0. Okay, so my driving force is going to be, we can refer to this formula just now. Okay, so my driving force multiplied with V equal to 92160. Therefore, my driving force is going to be 92160 over V minus frictional force is given by kV, by K equal to 40. So it's going to be 40V. Okay, minus M is 1200, G is 10, and sine theta is 0.15 is equal to 0. Okay, so you can multiply everything with V, so it's going to be 40V square plus 1800V minus 92160 equal to 0. So in order to find your V, you can use your negative B plus minus square root B square minus 4AC over 2A. You can use the quadratic formula to find the V, where V is equivalent to 30.5. Okay, so you just need to know that how we call the diagram. Okay, the vertical part here is not really useful because the friction force is already given as kV, so we no need to find the normal way. Okay, we use the fr as a kV and so on. Okay, now let's move on to the very last question. A particle p move in a straight line. Particle p move in a straight line with velocity pass through O with a velocity of 4.2. So means when t equal to 0, s equal to 0, my v equal to 4.2. After t pass through O, acceleration is given by this, and my a is given by 0.6 t minus 2.7. Okay, find the distance p travel between the time at which it has an instantaneous rest. Okay, so means I need to find the times where v equal to 0. So I find the time when v equal to 0 first. So means I need to find the v first. Okay, so v is equal to integral a dt, which is going to be integral 0.6 t minus 2.7 dt. So it's going to be 0.6 t square over 2 minus 2.7 t plus c. So this is my v. So at t equal to 0, my v equal to 4.2. So 4.2 is equal to substitute 0, 0, so c equal to 4.2. Okay, therefore my v is equal to 0.3 t square minus 2.7t plus 4.2. So solve this quadratic equation. Okay, solve this quadratic equation. So when v equal to 0 is going to be 0.3 square minus 22.7t plus 4.2 equal to 0. So you can use the quadratic formula. Your t is equal to negative b plus minus square root b square minus 4ac over 2a. Okay, so I got my t is equivalent to 7, my t is equivalent to 2. Okay, so it's going to be just integrate. In order to find the s, it's going to be 2 to 7, 0.3 t square minus 2.7 t plus 4.2 dt. Okay, remember your s equal to integral v dt. Okay, so it's going to be s equal to 0.1 t cube minus 2.7 divided by 2 is 1.35 t square plus 4.2 t, 2 to 7. So you sub in, so it's going to be 0.17 cube minus 1.357 square plus 4.27 minus 0.12 cube minus 1.352 square plus 4.22. Okay, so you will get, so here you get negative 6.25. But since the question here asks for distance, okay, it's going to be modulus of this, which is going to be 6.25. You just take a more positive answer because the negative just indicate the particle is behind the O. Okay, so we take the distance will be 6.25. Okay, so that's all from me. So if you have any questions regarding the paper 4 October number 2024, so you can comment on the video, so I will can give you further explanation on any questions that you think you need a further clarification from me. That's all from me. Thank you.